राधे राधे मेरे भाई हो. Today I am going to solve a new Leetcode question 239 sliding window maximum. You are given an array of integers. Let me take a pen. You are given an array of integers nums. There is a sliding window of size k, which is moving from the very left to the right. Can oversee the k numbers in the sliding window. Each time the sliding window moves right by one position. So he's saying return the max sliding window. He's saying you need to find the maximum in every sliding window of size k. You need to find maximum, and every time window will slide by one position to the right. I will explain by taking a test case. Sorry, yes. Let's move further. Test case is 1 3 minus 1, 1 3 minus 1, minus 3 5 3, minus 3 5 3, and 6 7, and k is 3. Means you have the sliding window of size k, means you have given a window already, k is equals to 3, and you have to find maximum in every window of size k. This is just first window of size k. This will be a second, this will be a third, this will be a fourth, this will be a fifth, this will be a sixth, seventh. Means seventh is not present, so this is the sixth sliding window. Okay, so 1 3 minus 1, minus 3 5 3 6 7, and k is equals to 3. Means it's saying in this sliding window you have to return an array in which every window of size k will, like, we have to return the maximum in every window of size k. So this is the first window, so what is the maximum in this window? 3. So array will contain 3. Now window will slide by one position to the right. How it will move? Sorry, this. Now window will be this. So what is the maximum in this window? Again 3. Now window will move by one position again. So what is the maximum in this window? 5. Now window will move by 1. So what is the maximum? Still 5. Now window will move to one position. So what is the maximum in this window? 6. Now 3 6 7, so maximum will be 7. Now window is crossed to the up end, so this will not be a valid window because only 2 elements are there. So you need to return this array as answer. Means what question is saying, we have to return an array of some size in which you have to find all size of k, means maximum element of all size of k window. So what approach you can think of? Let me change the color. 1 2 3 2 5 3 3, k is equals to 3. So as you know how to maintain a window, like j minus I plus 1 is equals to means this is the formula to find the size of the window. So if somehow you able to maintain the size, how can you find the maximum? Can you again use a loop to traverse to this window, and you can take a max variable every time. So it will give a maximum of this window. So you will directly push into the answer array 3. Now again, if you attend this window, you can again use a loop to traverse in this window, and you can find the maximum and put in the answer. Again, this window you can traverse a loop again after attending this window and can return the maximum. So this is the brute force you can after. Means what are the steps to write a brute force? First, attend size k window. Then second step will be traverse to the window and find max. So it will be O of n for sliding window, on and k of size every time, like you are traversing k every loop. So it will be not feasible in the bigger test cases. So what can be the optimal approach for this? 1 3 minus 1 2 3 4 5 minus 3 2, k is equals to 3. So what can be the optimal approach I can think of? Like in every window I need to find the maximum, right? Like after attaining window, I need to find the maximum element in this window. So he is talking about the maximum element. So whenever something is given like maximum at some instant, minimum at some instant, so your mind should go through the priority queue, because priority queue does, like, it will give you the maximum and minimum at any given point. Like whenever you find the top of the priority queue, it will give either maximum or either minimum depending on the priority queue which you have declared earlier. So as I thought of, like, and every time I have to maintain some window, and then in this window I have to find the maximum. So can I think of priority queue? Yes, as I already said, like whenever they talk about maximum or minimum element at any given point, he will give you the maximum. So like whenever I was maintaining the window, like see, first priority key was nothing was there in the, so first I is at 1, sorry, I and j are at the starting index. Okay, so j is at 0 index, so I will put into the priority queue with index. Make sure you are putting index, and why I will tell you later. So 1 is put at 0 index. Now j will move further, j comes here, 3 will put it as 1 index, right? Now minus 1, j is here at minus 1, so minus 1 is here at 2 index. Now as you can see, j is here, so j is at 2 index, 0 1 2 3. First let me write all the indices, 4 5 6 7 8. Okay, so as j is at 2 index, so j minus I plus 1 is equals to k, means this is the formula to find the size of the window. So 2 minus 0 plus 1, that is equals to k, means 3 is equals to k. Yeah, 3 is equals to 3, means you are right, you have attained the window. Now what I told you, like after attaining the window, after attaining the sum window, you need to traverse through this window to find the maximum. But instead of this, what I already put in the priority queue. So when you put anything in the priority queue, the max priority queue, so the maximum element will be the top. So priority queue will arrange by itself only. So 3 will come at the top, then 1 will at the after 3, and then minus 1 will be at the after 1. So priority queue does like rearrangement. The I am taking max priority queue because I need maximum at any instant of time. So 3 is at the top. So as you can see, like this is the window, like I was the starting and j was the ending of this window. So if any element in the priority queue range between this, means if I am the top of the priority queue and that element with his indices is between this range, means you can say that the maximum element is between this range. Okay, so as 3 is the top of the element and the index is 1, means as the index is 1, and what at 1 at which window I am, from 0 to 2 index. So 1 is between 0 to 2. Yes, 1 is between 0 to 2, means you can say that the top element, like what I said you, means every time at the priority queue the top element will be there, right? So as you can see, 3 is the top element in this window, right? So what is the index? 1, means as you can see the 1 is between 0 to 2. Okay, 1 is greater than 0 and less than 2, means this 1 is the, means 1 lies between in the window, means the top will be the maximum. So I can put into the max, I will put into the answer, like take as answer is this array. Now what I will do, let me 1 3 minus 1 2 3 4 5 2 3 4 5 minus 3 2. So first was this was the window, priority queue was like 3 2 minus 1 with the indices of 1 0 and 2. Okay, so as I think that the top element with indices 1, means the top element we also will always be the maximum element, and the index is what, 1, means 1 lies between 0 to 2, means this will be the maximum of this window. So I will directly put it to answer 3. Okay, now window will slide by 1, and now I will put the maximum. Now I'll put the element into the priority queue. So 2 will be put here, and the with indices of 2, because this is 2 index, 3 index, 3. Now again see, now I am at what range, I is equals to 1 and j is here. So as you can see, still at the top of the priority queue 3 is there, means 3 is the maximum element, and is the 3 lies between this range, I is equals to 1 and j is equals to 3. 1 lies between 1 and 3. Yeah, 1 lies between 1 and 3, means 3 is the maximum element for this window. 3 is the maximum element for this window. Now I will move the window by 1 position. Now how it will move? So the new window will be new window will be 1 minus 1 2 and 3. So if I put minus 1 and 2 and 3, now let me again draw the priority queue, 3 1 2 0 2 3 and minus 1 2. Now if I put 3 the new window was what, minus 1 2 3, again I put into the map. So 3 will come as a 3, index was 4. Now as you can see, the top element is what, 3, and now 3 has index what, 1. So 1 lies between 2 and 4. No, so one line means, as you can see, the top of the element is not in the range between this window. Means this, you cannot put this element as the maximum. Why you cannot put this? Because the indices with that element is out of this range. Means I is 2 and j is 4. Means 1 is less than 2. Means this is out of the window. So what you have to do? You have to pop out that element. So you will pop out that element. So if you pop the element, so the element will be popped and the new element will be like what? 3 as the indices 4. So now as you can see, the new element at the top is 3. Okay, and indices is 4. So is index is lies between 2 and 4. Yes, this index lies between 2 and 4 means this can be the maximum of this window. Yeah, as you can see, in this window 3 is the maximum. So we'll put 3 in the maximum array. Now again I will write the window by one position. Again move the window by one position. So if I move this, the new window will be like 2 3 4. Okay, now I'll put 4 into the map. So 4 is the maximum, so will come at the top with indices 5. So now I is what? I is 0 1 2 3 and 4 is what? 5. So as you can see, the maximum element index is 5. Is this lies between this range? Yes, this lies between this range. Means 4 can be the maximum element for this value. As you can see, for 2 3 4 window, 4 is the maximum. So directly put 4 in the answer. Now again 3 4 5, the new window. So 5 we will put there. 5 with indices 5 6, sorry. So is 5 lies between the window? Yes. Now I is 4 and j is 6. So 6 lies between this. Yeah, 6 lies between this. So you can directly put the top of the element. So what I want to say is 1 3 minus 1 2 3 4 5 6 7. What I want to say is, if you are at any time this in this window, right? So the maximum element should be in this range from I to j. If maximum element is beyond this and after this won't be calculated as the maximum for this window. So as in the priority queue, you are putting element with element as well as indexes with his index, element with his index. So the at the max priority queue, the top element will be the maximum. But still, if it is a maximum and the maximum is beyond this window or after this window, will it be counted as the maximum for this window? No, because this is out of the window. You cannot take it as a maximum for this window. So we'll keep popping out the max element until it lies in the range. Okay, so like see, assume I took this window. Okay, and the max somewhere 6 was there here. Okay, so a map will be look like 6 will be top, 3 1 and 2 3 4, 2 3 4. Now 6 is at the top with index what? 2. So as you can see, for this window maximum is what? 4, but at the top you can see 6 is there, means 6 is out of the bound, means 2 0 1 2 3 4 5. This is the index, right? So each 2 lies between these indices 3 to 5. No, it's not, it not lies between this index. So I will pop out the 6, means this is out of the range. Now the top element will be 4 3 3 2. Now as you can see, 4 with indices 5. So is lie between 3 to 5. Yes, it is lie between 3 to 5. So simply put the top of the element to the answer array. So I hope you got the intuition what I want to say. I want to say, like, take a priority queue. Okay, as I took the priority queue, I will put max priority queue. Fine. So the max element will always be the top, and if it is a max, it should lies between the given window. Means if the window is from 0 to 3, the maximum element lies between these indices only, not beyond this and not after this. Okay, so I will add the pseudo code. First I will declare a priority queue int. I have to take pair of, so I will declare a pair of, because I am putting element with his indices, so that I can track whether it is beyond or after the window or not. So pq will be like this, and I will run a loop till I less than n and j less than n. It should not go out of the bound. So like what I was doing, first I was putting into the map, priority queue. So it will be like array of j with indices j. Okay, I put into the map, put in the priority queue. So at what time I have to check whether the maximum element is beyond the priority queue or after the, if the window is k, window size is k. So how to find the window size? I already told you j minus I plus 1 is equals to k. So if j minus 1 equals to k, means you are able to find the window size. Now if at anyhow priority queue dot top like top is containing what element with indices. So pair was this, so pair first is denoted as dot first and second element is denoted as second. So if priority queue dot top dot second means if index lies between greater than equal to I and pq dot top dot second means the indices less than equal to j, means if it is in the given window range means this is the element, sorry, this is the element, wait, yeah. So if this is the bit, if this is in the range means the top element of the priority queue is the maximum of this window. So if this, if this lies in the range, so I will simply put into the answer dot pushback pq dot top dot first will denote the element and second will denote the index. Now if else, like it can be a condition that the it can be a condition that the element is beyond the priority queue. So what I will do, I will keep popping out the element from the priority queue while, and also I will make sure that priority queue size should be greater than 0. Means if you do not have any element in the priority queue, you cannot pop out. So while pq dot size is greater than 0 as well as pq dot top dot second means I am talking about indices, is if it is less than I, means if it is beyond the, like if you have a window of 0 to 3, sorry 1 to 3 and the top and the maximum is at 0 index, so would you take it? No, I would not take it because it is beyond the window. So if it is less than I will keep popping the element from the priority queue. Okay, and at the end what I will do, I will simply, I was putting every element into the map, sorry into the priority queue. What, why I'm telling map every time, j, and every time I was incrementing j. And after attaining window you need to also increment the window by one size I plus plus. So again I will write the whole code as it looking bit messy, so I will write the whole code again. I am declared the priority queue max with a pair priority queue pair int pq. Okay, now what I will do, I will run a loop till n while I less than n and j less than n. Okay, so n is what size of the array. So every time I will put element with his indexes in the map, so I will put array of j along with the index. Okay, and if somewhere I got the window size equals to k, I will do some checks whether the top is, so at after attaining the window I have to check whether priority queue dot top dot second means if the top index is lies between this I and less than equal to j means this is a valid. So I will simply put into the answer was the array answer dot pushback. What I will put, I will put the element which is the max. So priority queue dot top dot first, it will give you the element. Else if like if the element is beyond the range means beyond the size, so what I will do, I will keep popping out the priority queue dot top dot second. If it is less than I means the element is, the maximum element is beyond the size means I do not have to take it, so I will keep popping out pq dot pop. Okay, and after in I plus, why am I doing I plus first, let's 1 2 3 4 5 6, I was here, j was here. So j, when j comes to here, this you are able to attain the window. Now you have to slide the window. So what I will do, you will simply increment I 1 and every time you are incrementing j, so it will again takes a new size of k. So I plus plus, and after the loop every time what I was doing, incrementing j plus plus, and at that simply return the answer. So let me summarize what I did. First the brute force was after maintaining k, traverse through the window and then find maxi. Okay, and optimal was what, I will take priority queue. Why I'm taking priority queue, because at any instant if I want a maximum or minimum attainment, I need to think about the priority queue. Second thing, if the priority queue top is lies between I top to j means this is between the window. If this is the window means the top element will the maximum for this window. Okay, and if the top element is beyond the I, now we got why I have taken index as well as the element, because index will give you will give you access to track the element at what index that element was. So if the top element is beyond this index, means it cannot be a maximum. I need to take maximum between these range. So I will keep popping out the element until it is beyond this window, and if somewhere I got the element which is between this range, I will take that element. So I hope you understand the question as well as the logic. So I will be meeting in the next video. Till then, take care. Bye bye. Jai Shri Ram.